Have you ever wondered how microcontrollers work? Specifically, the 8051 microcontroller. These tiny yet powerful devices are at the heart of countless technologies, from your digital watch to complex industrial machinery. The 8051 microcontroller is one of the most popular architectures, renowned for its versatility and robustness. It's found in a wide array of applications, from home appliances to embedded systems. It's a fascinating world to explore, filled with intricate programming and endless possibilities. Now let's dive into how you can program an 8051 microcontroller. First, set up your development environment. The heart of your programming journey starts with choosing the right integrated development environment, or IDE. Now, there are a number of IDEs that are perfectly suited for 8051 microcontroller programming. Notable examples include Keil UVision, known for its user-friendly nature, and SDCC, the small device C compiler, praised for its flexibility. Each IDE has its own unique features and strengths, so it's all about finding the one that aligns best with your needs and comfort. Once you've made your choice, it's time to install the necessary software and tools on your computer. This process might involve downloading compilers, debuggers, or other utilities that your IDE requires. It's like setting up a toolbox before you start building, and just like that, your development environment is all set up. With the development environment ready, move on to the next step. Next, write or load your code. Dive into the world of microcontroller programming by crafting your code using a language that's compatible with your chosen development environment. You're free to use assembly language, which gives you granular, low-level control, or C, which offers a higher-level abstraction. It's like choosing between a scalpel or a Swiss Army knife, each with its unique advantages. If you're just starting out, don't fret. You can also use existing code or example projects as your starting point. This way, you can learn by dissecting and understanding how the code works before you start writing your own from scratch. It's like learning to cook by following a recipe before creating your own culinary masterpiece. Remember, the code you write will dictate how your 8051 microcontroller behaves, so take your time and be precise. With your code written, it's time to understand the architecture of the 8051 microcontroller. The 8051 microcontroller has a specific architecture you need to understand. At the heart of the 8051 microcontroller is the Central Processing Unit, or CPU. It's the brain of the system, responsible for executing the instructions of your program. The CPU interacts with the rest of the 8051 architecture, including memory, input-output ports, timers, and other peripherals. Now, let's talk about memory. The 8051 microcontroller has a unique memory organization. It comprises two main types, RAM and ROM. The random access memory, or RAM, is where the microcontroller stores temporary data during operation. The read-only memory, or ROM, is where the microcontroller stores the program code. The 8051 also features a remarkable set of input-output ports. It has 4 8-bit ports, providing a total of 32 lines that can be used either for input or output operations. These ports can be programmed to interface with external devices, such as sensors or LEDs, offering a wide range of possibilities for your projects. Timers are another significant part of the 8051 architecture. The microcontroller comes with a pair of 16-bit timers/counters. These timers can be used for time management, event counting, or generating precise time delays. They can also be configured to generate interrupts, which can be useful for multitasking or handling time-critical operations. Other peripherals such as serial communication interfaces and interrupt handling systems further enhance the capabilities of the 8051 microcontroller. These systems allow the microcontroller to communicate with other devices, manage multiple tasks at once, and respond to specific events in real time. Lastly, we have the Special Function Registers, or SFRs. These are a set of registers that control various aspects of the microcontroller's operation. They manage everything from port input-output to timer control to interrupt handling. Understanding how these registers work is crucial to mastering 8051 programming. Understanding the architecture of the 8051 microcontroller is fundamental to programming it effectively. Input and output operations are fundamental in microcontroller programming. The 8051 microcontroller is equipped with multiple I/O ports, which you can configure for a variety of purposes. So, how do we handle these operations? Think of I/O operations as the microcontroller's way of communicating with the outside world. It can receive inputs from switches, sensors, and other devices, or send outputs to control LEDs, motors, and more. For instance, to read an input from a switch, you would configure the relevant I/O port as an input port, then read the voltage level at the port. If the switch is pressed, the voltage level changes, and you can detect this change in your code. On the other hand, to control an LED, you would configure the I/O port as an output port. By changing the voltage level at the port, you can turn the LED on or off. Well done! You can now handle I/O operations. Timers and interrupts are crucial for time-sensitive tasks. In the heart of the 8051 microcontroller, there are built-in timers and counters that you can configure to generate interrupts at specific intervals. These features are indispensable when you need your program to perform certain actions precisely when the time is right. Think of timers as your microcontroller's alarm clock, ticking away in the background, and when the alarm goes off, it triggers an interrupt. This interrupt then prompts the microcontroller to temporarily pause its current task and execute an interrupt service routine, or ISR, a special function written by you, the programmer. Writing ISRs demands careful planning. Your ISR needs to be efficient and quick because while it's running, the rest of your program is on hold. So remember, keep it short and sweet. Once you've mastered the art of using timers and programming ISRs, you've unlocked a powerful tool in your 8051 programming toolkit. With a grasp of timers and interrupts, you're ready for the next step. Communication with other devices is often a key part of microcontroller applications. Let's dive into some common communication protocols used with the 8051 microcontroller. First up, we have serial communication, or UART, which stands for Universal Asynchronous Receiver and Transmitter. This protocol is used for communication between the microcontroller and other devices such as PCs, GPS modules, or GSM modems. Next, we have the Serial Peripheral Interface, or SPI. This protocol is used for communication between the microcontroller and peripheral devices, such as sensors, South Dakota cards, and shift registers. Finally, we have the I2C protocol, or Inter-Integrated Circuit. This is a multi-master, multi-slave, packet-switched, single-ended serial computer bus. It's used for attaching lower-speed peripheral ICs to processors and microcontrollers. To send and receive data using these protocols, you'll need to implement specific code in your program. This might involve setting up registers, defining baud rates, and handling data transmission and reception. You're now equipped to handle communication protocols. Once you've written your code, it's time to debug, test, and document. These are crucial steps in the programming process that ensure your code runs smoothly and is easily understood by others. Let's start with debugging. Debugging is the process of identifying and fixing errors in your code. The development environment you've chosen for your 8051 programming project likely comes equipped with its own debugging tools. These tools allow you to step through your code line by line, inspect the values of variables, and observe the flow of execution. This is an invaluable weapon in your arsenal, as it allows you to pinpoint exactly where your code is going awry. Next, we move on to testing. Testing your code is essential for ensuring it behaves as expected, under a variety of conditions. Consider using a mix of manual and automated testing methodologies to thoroughly vet your code. Manual testing allows you to interact with your program and observe its behavior firsthand, while automated testing can quickly and systematically check your code against a suite of test cases. Remember, the goal here is not just to ensure your code works, but to ensure it works reliably and consistently. Lastly, we can't overstate the importance of thorough documentation. A well-documented codebase is easier to understand, maintain, and extend. It's a good practice to include comments in your code explaining what different sections do, how they do it, and why they do it that way. Additionally, document your pin connections, memory usage, and any specific hardware configurations. This will make it easier for others, or future you, to understand your code and its dependencies. While debugging, testing, and documenting, don't forget about power considerations and memory management. If you're working on a battery-powered application, Optimizing your code and using sleep modes when appropriate can conserve power. Understanding how the 8051 microcontroller manages memory can help you optimize your code for efficient use of available memory. Congratulations! You're now well equipped to program an 8051 microcontroller. Well, there you have it. We've journeyed through the fascinating world of 8051 microcontroller programming, from setting up our development environment, writing and loading code, understanding the 8051 architecture, to handling I/O operations, utilizing timers and interrupts, and mastering communication protocols. We've also delved into the crucial steps of debugging, testing, and documentation. As you continue your exploration, remember the importance of memory management and power considerations. Remember, practice makes perfect. So keep exploring and experimenting. Happy coding!